So we have Unit 11, and we're talking about some of the vocab words that we discussed yesterday. So the first across clue is an organized method of showing all possible outcomes of a probability experiment. Yes. What is it? List. 4 letters, and that's the only 4-letter word. All right. Value. Sorry, I'm sharpening a pencil. A value between, well, that defeats the purpose because the pencil edge just broke. Between 0 and 1, used to describe the likelihood that an event will occur. Probability. It was this pencil that broke its lead. You got lead for this one? Just kidding. Yes, you can.
I do.
Probability. All right. Ladies, gentlemen, are y'all done? Okay, if you're moving on, your mouth should not be moving. If you're catching up, your mouth should still not be moving. Stay focused without talking. Across, number 8, the set of all possible outcomes in a probability experiment. Sample space. A possible result or outcome in probability, a subset of sample space. Event, good. You don't need to do that to my stapler. One hand, squeeze it, and that's it. Don't punch it down on the table. Don't do that because that's how it breaks and that's how it gets jammed. Okay. Down. 1 down. A diagram used to show the total number of possible outcomes in a probability experiment. Tree diagram. A test or trial in which the result is uncertain. Experiment. We don't know what happens, so we're going to experiment to see what will happen. One outcome from a sample space. 2 words. A simple event. 1 outcome. What's more than 1 outcome? A combination of 2 or more outcomes. Compound. So I'm going to go straight to 6. And number 5, the word, one of the words that I have left, outcome. I'm sorry, the only word that I have left. I've used every other one. All right, so let's move on. So it says a sample space is a list or diagram of all possible outcomes of an event. When representing a sample space, it is important to consider each event and the possible outcomes separately before creating a list or diagram. Cameron has 2 marbles in a bag, 1 blue and 1 red. He also has a 6-sided number cube. How many combinations of 1 color and 1 marble, or 1 color of marble, and 1 roll of the number cube can Cameron make? Choose 1 event to occur, which is drawing a marble from a bag, and then list all the possible outcomes, blue and red. Then choose the number cube option. What are the outcomes? 1 through 6. Begin a tree diagram by listing the outcomes from 1 event horizontally. They wrote the blue and the red first. Put my stapler down. Oh, okay, thank you, but still put it down. Then list the options or the outcomes in branches from each event of the first one. So I can make a blue, I can pull a blue marble and roll a 1. I can pull a blue marble and roll a 2. A blue marble and roll a 3, and so on. Thank you. Then I can do the same thing for red. red and roll a 1, red and roll a 2. How many total possible outcomes are there?
12.
I've heard 2 answers. I want 1, and I want the correct one. Yes. 12. Count the branches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Furthermore, if you read along, you would see the number 12 down there at the bottom. When completed, count the number of branches on a tree diagram or the number of entries in a list to determine the total number of possible combinations for the event. So this is making a list. They wrote blue and 1, blue and 1, blue and 2, blue and 3, blue and 4, blue and 5, and blue and 6. Gentlemen. Then they did the same thing for red. And they have a total of 12 entries in the list and 12 branches at the very end of this tree diagram. Sometimes tree diagrams can have 2 layers. This is just 1. Okay? So try it yourself. Amanda looks in her drawer and finds 1 blue shirt, 1 red shirt, and 1 green shirt. Guys, if I'm circling important information in a question, I need you to do the same. Because I've looked at your tests and your quizzes, and y'all aren't doing that, and it's throwing some of you off. So it's best to just do it anyway, so that you've covered all your bases and made sure that you've taken out the important information in your question. And if I don't do it, then somebody needs to say, hey, Miss Starling, you need to circle your important information. Keep me in check too, please. She also finds 1 pair of each black, khaki, and blue shorts. Create an organized list and a tree diagram to determine the number of combinations of 1 shirt with 1 pair of shorts that Amanda can make. So they're always going to want to know about 1 shirt and 1 short or pair of shorts. Okay? Because you can't wear 2 shorts at the same time. Well, you can, but for math's sake, you can't. They want 1 and 1. 1 shirt, 1 pants, or a bottom. So, according to this up here, what did they do first? They labeled what? What did they label, though?
The number rolled and marble color.
Okay, what did they do first? They did do the number rolled and the marble color, but what did they do first in their tree? The color of the marble. So what am I going to do first here? The colors of the shirt, because that's what they give me first. Gentlemen. So, how many shirts do I have to choose from? 3 shirts. How many colored shorts will I have to choose from? 3 pairs of shorts. So if I were to predict a number of combinations, what will it be? What would it? I heard 6 and 9. What did I get up here? I had 2.
12.
Excuse you.
You'll get 6.
I had 2 colored marbles and 6
Oh, you'll get 9.
on a number cube.
The answer's 9.
And then I got 12. What did I do with the 2 and the 6?
Multiply.
2 times 6. So what am I going to do with the 3 and the 3? And get what? 9 combinations. I heard 2 different numbers. I need everyone to understand why 9 is correct. All right? Yes, combos, short for combinations. All right, so the shirts, blue, red, green. Now, what do I put down here? Good. What color shorts? Do I put black here, khaki here, and blue here? How do I do it? One of each on each line. Black, khaki, and blue. black, I abbreviated black, khaki, and blue. Black, khaki, and blue. It is okay to abbreviate, but would it have made sense for me to put B for black and B for blue? No, it would not have, because they're two different colors and I would have used the same letter and been wrong. Now, in the table, yeah, you could color code, but I really want y'all writing in pencil anyway. In the table, I need to list the number of shirts and the number of shorts, or I'm sorry, the colors of shirts and the colors of shorts with each combination. So this first combination is blue and what? Black. The second combination is what? Blue and khaki. The third combination is what? Blue and blue. The next one is red and black. The next one? Yes, it is. Don't lose focus. Then I need to do green shirts with black shorts, khaki shorts, and blue shorts. Stop. Okay, next. Sarah draws a card from a standard deck. If the card is red, she rolls a standard die. If the card is black, she flips a coin. Oh, I skipped a page. I went to the very end. Oh, well. Go to page 112. Which of the following tree diagrams correctly displays the sample space for Sarah's experiment? So if she draws a red, what only other options can be combined with that? What's on a standard die? 1 through 6. And then what's on a coin? Heads or tails? If that pin clicks one more time, it is going to be mine. Furthermore, you should be writing in pencil. Excuse me, I didn't ask any questions, therefore there should be no discussion. So, with a red card, what are her options for rolling a die? Okay, this looks like it could be it because it's red and 1 through 6. This is red and 1 through 6. Can she get a heads and tails with her red though? No, because she's not flipping a coin. Is she flipping a coin with the red card? No again. Is she rolling a number cube and flipping a coin at the same time? That's definitely not it. So it's got to be what? A, because I've got a black card and I'm flipping heads or tails. That's it. All right, moving on to number 2.